The anabolic process of carbohydrates in relation to glycogen occurs in the liver and skeletal muscle and is actually exergonic. The formation of UDP glucose starts with the breaking of an anhydride bond and formation of a new one. These two reactions cancel out, and the outcome is a delta G naught prime of 0 kJ per mole. This reaction is coupled by catalyzation by an inorganic phosphate, which has a delta G naught prime of negative 19.2 kJ per mole that allows the reaction to drive forward. Next follows chain elongation that liberates negative 13.3 kJ per mole and the branching process with negative 8.4 kJ per mole, resulting in the synthesis being exergonic. Dietary polysaccharides are metabolized by hydrolysis and converted into monosaccharides. The breakdown of glycogen starts with glycogen phosphorylase cleaving the glycosidic bond with inorganic phosphate, which releases glucose 1-phosphate. Essentially, it removes glucose off the non-reducing end and phosphorylates them. Breaking of the bond and transfer of the phosphate, the delta G naught prime is 3.1 kJ per mole, but in the cell, delta G naught prime is about negative 5 to negative 8 kJ per mole, which makes this reaction exergonic. The debranching enzyme breaks the glycosidic bond and transfers 3 residues to the main chain, which results in a net delta G naught prime of 0 kJ per mole. What drives the process of the reaction is the breaking of the 1,6 glycosidic bond, which releases negative 7.1 kJ per mole. In patients suffering with Cori disease, the outer chains of glycogen are either missing or too short. This is an issue because the more branch points there are, the more non-reducing ends there are, which means cleaving cannot occur and glucose residues cannot be released. The lack of the debranching enzyme caused by Cori disease results in deformed glycogen structure because those 3 glucose residues cannot be transferred, hence the buildup of glycogen.